A bolt of measure diameter 12 mm is required to clamp two steel plates. Cross-sectional area of the threaded portion of the bolt is 84.3. That is the 80 value is given, and we have given the DO value is equal to 12. The length of the threaded portion in the grip is 30 mm, that is lowercase lt is given, while the length of the unthreaded portion in the grip LD is given as 8 mm. Young modulus of the material is 200. Effective stiffness of the bolt in the clamp zone we have to find out. So we represent here the two plates, plate 1 and the plate 2. To make the arrangement here, we have passed the bolt of diameter DO is equal to 12 mm. So in this case, we have given the nominal diameter DO is equal to 12 mm. The cross-sectional area of the threaded portion is 80. So 80 represent here the cross-section area of the threaded portion, that is given as 84.3 mm square, and AD represent the cross-sectional area of unthreaded portion, can be calculated as pi by 4 into DO square. That will be equal to pi by 4. DO is equal to 12, so we have 12 square is equal to 113.09 mm square. The length of the threaded portion in the grip, so this one is a grip here and this one is LT, represent here the length of the threaded portion in the grip, and this value is given as 30 mm. While the length of unthreaded portion in the grip is only 8 mm. We want to calculate here the effective stiffness, and addition to this we have given the Young modulus E, that equal to 200 gigapascal. So first of all, here we will calculate the stiffness of the unthreaded portion, then we'll calculate the stiffness of threaded portion, and then we'll use the series rule. So KD represent here the stiffness of unthreaded portion is same as equal to area of unthreaded portion multiplied by Young modulus E, which is common to both, divided by LD. The area of the unthreaded portion is 113.09 mm square, so we'll take it in meter, will be equal to 113.09 mm square will be equal to 10 to the power minus 6. Young modulus is given as 200 gigapascal is 200 into 10 to the power 9 divided by the length of unthreaded portion is equal to 8 mm. 8 mm is 8 into 10 to the power minus 3. So this quantity we have taken in meter square. Young modulus we have taken as Newton per meter square, and the length we have taken as meter. So unit of this quantity is Newton per meter. We have stiffness of unthreaded portion is 2827.25 into 10 to the power 6 will be Newton per meter. Since we required find out the answer in mega Newton per meter, so we'll divide by 10 to the power 6. So we'll get this answer equal to 2827.25 mega Newton per meter. Similarly, we can calculate here the stiffness of the threaded portion, that will be the ratio of area of the threaded portion multiplied by Young modulus divided by the length of threaded portion in the grip is LT. Area of the threaded portion he has directly given, because this value you have to collect from table, hence it was given to you as 84.3 is mm square. So again you have to multiply by 10 to the power minus 6, it will be meter square. Young modulus you have to take as 200 gigapascal is 200 into 10 to the power 9, and whole thing is divided by the length of the threaded portion equal to 30 mm. So that value of 30 mm you have to take in meter is multiplied by 10 to the power minus 3. The unit of stiffness will be same as Newton per meter. So we have stiffness is equal to 562 into 10 to the power 6 will be Newton per meter is same as equal to 562 mega Newton per meter. Since we have two spring will be in series, so we have 1 upon K, where K represent the equivalent stiffness is 1 upon Kt plus 1 upon Kd. Here we have to substitute the value as Kt equal to 562, so we have 1 upon 562 plus 1 upon Kd value is 2827.5, 2827.25. Take reciprocal and find out the equivalent stiffness K. This value is close to 468.25 is meganewton per meter. Pre-tensioning of the bolted joint is used to strain harden the bolt head. No, that is wrong. Decrease the stiffness of the bolted joint. No, the stiffness will going to increase. So choice C is correct. That is the increase the stiffness of the bolted joint. Choice C is correct choice. A bolted joint is used to connect the two components. The combined stiffness of the component, that is a member, is twice the stiffness of the bolt. So we have given here the Km is equal to 2 times the stiffness of the bolt, that is Kb. The tightening of the nut result in a preload of 6 kN in the bolt, that is the value of Fi is known, which is equal to 6 kN. When the external force 12 kN is applied, that is the value of P is equal to 12 kN. On the assembly, the tension on the bolt you have to find out. The value of the total force on the bolt Fb we have to find out. Value of Fb will be same as equal to the initial preload plus we have Kb multiplied by del delta. Total external load P is given as the stiffness of member plus the stiffness of the bolt multiplied by del delta. So from here we can calculate value of del delta and then we'll substitute and find out the value of Fb. And in addition to this, he has given the value of Km is equal to 2 times of Kb. So we have P is equal to, we'll find out this answer in the terms of Kb. So Kb will be get cancelled. So Km is replaced as 2 times of Kb plus we have stiffness of bolt multiplied by del delta. That is we have P is equal to 3 times of the stiffness of the bolt multiplied by del delta, or we have del delta is equal to P divided by 3 times of the stiffness of the bolt. So we'll put this value in equation 1. So resultant load due to preload and the external load on the bolt is given as Fi plus Kb multiplied by del delta, which is equal to P divided by 3 divided by Kb. Here Kb and Kb will cancel out and we have given the initial preload is equal to 6. So we have 6 plus external load is given as 12. So we have 12 divided by 3. 12 divided by 3 is 4. 6 plus 4 is equal to 10. So resultant load on the bolt will come out equal to 10 kN. A bolted joint is used to connect the two components. The combined stiffness of the component, that is the Km, is 1/3 of the bolt. So we have given here the value of Km equal to 1/3 of the stiffness of the bolt equal to Kb. If the bolt is initially tightened to the preload of 10 kN, so preload Fi, initial load Fi is equal to 10 kN. What is the maximum load in kilonewton the assembly can take? Assembly can take the maximum load equal to P, that is the external force P. So maximum load P we have to find out. The maximum load P is same as equal to the stiffness of member plus the stiffness of the bolt multiplied by del delta, and he has not given the value of del delta. Here we are familiar with this graph. We have Fi is the initial load, Fb is the resultant load on the bolt. Fm represents here the load on the gasket, and the value of Pb plus Pm together will be equal to P. So if we have a maximum value of P, in that case the Pm contribution will increase and the Fm value will become 0, that is come to origin. So this one is representing here the maximum value of contribution due to the member. So this one is PM max. In that case, the value of FM will be equal to 0, and we have the maximum force will be equal to PM max plus PV. So here we'll assume that the value of FM will be equal to 0. The resultant force on the member is nothing but PM max. So we have PM maximum value minus Fi will be equal to 0. The maximum value of the member PM max is simply equal to Km multiplied by del delta max. So this value you have to make it max. I will just write here del delta is same as equal to the initial load Fi. We can find out here the expression for del delta. So we have del delta is same as equal to Fi divided by Km. So this one is our equation number 1. This one is our equation number 2. And when we substitute for del delta in equation 1, so from 1 and 2, maximum load P is equal to Km plus Kb multiplied by del delta, which is initial load Fi, that is a preload, divided by Km. Now we have to solve this equation. Since this term is Km, it is better to substitute for Kb is equal to 3 times of Km. So we have maximum load will be equal to Km plus 3 times of Km divided by Km multiplied by initial load equal to Fi. So this value will be same as equal to 4. So we have 4 times of Fi, and we have Fi is equal to 10. So in this case, we have maximum load will be equal to 40 kilonewton. Two circular plates are clamped by means of a bolt. Initially, the nut is tightened by means of spanner so as to induce a preload of 2.5 kilonewton. We have given the preload Fi is equal to 2.5 kilonewton. The external force acting on the assembly is 5 kilonewton. Value of P is given, that equal to 5 kilonewton. Effective stiffness of the part held together by the bolt is 3.5 times the stiffness of the bolt. So we have given the value of Km is equal to 3.5 times the stiffness of the bolt. Equivalent force acting on the bolt due to preload and the external load you have to calculate. That is the value of FB we have to calculate. FB value is same as equal to Fi plus del delta multiplied by stiffness of the bolt. Since he has given the value of P, the value of P, that is the external load, is due to the sum of the force contributed by member plus bolt, that is the value of Km plus Kb multiplied by del delta. We have value of P is given as 5, and we have relation between Km and Kb. So first of all, we'll solve for P. We have Km equal to 3.5 times of Kb plus Kb multiplied by del delta. From this we can solve for del delta. So we have del delta is equal to P is 4.5 times of Kb. So let's say equation number 1, and this one is equation number 2, and we can substitute for del delta in the form of Kb. So Kb will get cancelled. So equivalent force on the bolt is Fb is equal to the preload, that is initial load, equal to Fi plus del delta is equal to P divided by 4.5 times of Kb multiplied by Kb. So Kb and Kb will cancel out. We have initial load, that is a preload, is equal to 2.5. External load is equal to 5 divided by 4.5. So this total value come out to be 3.61 kilonewton. The ratio of the load required to open the bolted joint to the initial tightening load with the stiffness of the mating part is equal to 3 times the stiffness of the bolt. Mating part has a stiffness equal to Km, and this value is given as 3 times the stiffness of the bolt. The ratio of the load required is P divided by the initial tightening Fi we have to find out. Whenever we have to open the bolted joint, that time we have to take the value of Fm, which is equal to Pm minus Fi must equal to 0. And the contribution of Pm is same as equal to Km multiplied by del delta. So in this case we have Pm is Km multiplied by del delta equal to Fi. So from here we can calculate the value of del delta. We have del delta is equal to Fi divided by Km. To find out the ratio of P divided by Fi, we'll try to find out this value in terms of Km. So we know the value of P is equal to Km plus Kb multiplied by del delta. So we have Km. This time we'll replace the value of Kb in terms of Km will be Km divided by 3. And del delta will put as Fi divided by Km, so that the value of Km will be get cancelled. That is why you substitute here for Kb is equal to Km by 3. So Km will be get cancelled from numerator and denominator. This one is 3 plus 1 is 4 by 3 times Fi. So we have P is equal to 4 by 3 times Fi. It means that we have required ratio P divided by Fi is same as equal to 4 by 3. 4 by 3 is equal to 1.33. A cast iron cylinder head is fastened to cylinder of bore equal to 500 mm with the 8 stud bolt. The maximum pressure inside the cylinder is 2 megapascal. The stiffness of the part held together by the bolt is 3 times the stiffness of the bolt. What is the initial load in kilonewton on the bolt such that the joint separates at a maximum pressure? Initial load, that is the preload, we have to calculate. We have given here the cylinder whose inner diameter equal to 500 and is joined with a 8 number of bolt. And the inside pressure is also given equal to 2 megapascal. External force is not given this time. External force will be same as equal to the pressure inside the cylinder multiplied by the area of the cylinder. Consider here a cylinder arrangement. This one is the body of a cylinder. This one is the top cover. We have a gasket here, and this one you have given a pressure. So pressure will act on the area whose inside diameter is given as 500 mm. So this diameter is known to us, that equal to D is equal to 500 mm. And the pressure is given equal to 2 megapascal. This force is exerted on this area. So we can calculate here the external force, that is the total force acting. So we have F total will be equal to the pressure multiplied by pi by 4 into diameter square, that is the diameter of cylinder. From this we have pressure is known to us is 2 Newton per mm square multiplied by pi by 4 multiplied by d square equal to 500 square of it. We have taken the pressure as Newton per mm square and area we have taken as mm square. So this time we have force is in Newton, is close to 392,700 Newton. This force is opposed by 8 number of bolts. So these are the total 8 number of bolts are holding the head with the cylinder body. So external force developed in the bolt will be equal to P external is same as equal to total force divided by the number of bolts. Total force is 392,700 and we have number of stud bolt used is equal to 8. So each of these bolt has an external force is equal to 49087.5 Newton. That is equal to 49.087 kilo Newton. So indirectly he has given the calculation procedure for finding the value of external force. The stiffness of the part held together by the bolt is 3 times the stiffness of the bolt. So we have given the value of stiffness of the material Km equal to the stiffness of the bolt but 3 times. So we have 3 times the stiffness of the bolt. We want to calculate here the initial value is equal to Fi. He says that the joint will separate at a maximum pressure. When the joint will separate in the maximum pressure, the value of Fm will be equal to 0. But the value of Fm will be same as equal to Pm. Initial preload is equal to Fi must equal to 0. Pm we can write as Km multiplied by del delta minus initial load Fi is equal to 0. We can find out the value of del delta in terms of Fi and Km. So we have del delta is same as Fi divided by Km. Let's say we have del delta equal to Fi by Km equal to equation number 1. Since we have given the value of F external, so we have F external is same as equal to Km plus Kb multiplied by del delta. Here we'll substitute for del delta is equal to Fi by Km, and external force in each bolt is 49.087, and we have given the value of Km equal to 3 times of Kb. But since it is divided by Km, it is better to replace Kb is equal to Km by 3. So we have F external is same as equal to 49.087. Km will keep as it is because we want to cancel it. Kb value will be equal to Km divided by 3, and del delta we can write as Fi divided by Km. So Km and Km will be cancelled out, and this value is same as 4 by 3. So we have 49.087 is equal to 4 by 3 multiplied by Fi. So approximately we have preload which has come out to be 36.815 will be kilonewton. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.